Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Kadyn. And Kadyn, if somebody needed to get in contact with us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Kadyn, why don't you let everybody know where you go to school and what grade you're in?
I am in Bill L. Williams, and I'm in 6th grade.
How's 6th grade going?
It's going very good for me.
Good, glad to hear that. Have you been at Williams for a long time?
Yes, I have, for as long as I can remember.
So since kindergarten?
Yes.
All right, so well, it's going to be a little different next year then when you go to junior high. Whole new school, whole different atmosphere. You've been someplace for 7 years. Are you looking forward to anything when you get to junior high?
Not really.
Okay, well, you've got a whole year to think about it, right?
Yeah, I got a whole year.
All right. Now, I know that in school, in 6th grade, at the beginning of the year, you guys work on ratios and proportions.
Yes,
All
that's
right.
correct.
Head on over to the board for a quick moment. You and Scott, I'd like you to discuss the different ways to represent ratios.
Okay.
All right, so you can grab a pen and you can go ahead and put stuff up there and talk to Scott as you're doing it.
Okay.
So maybe come on this side of the board and take it away.
So the first way to write a ratio is doing it with a colon. So it's simply like 6 colon, and let's think of number 9. That's the way to write it with a colon.
Okay.
Another way to do it is you could use words. So let's use the same ratio, 6 to 9.
Okay, and those two things mean the same thing.
Those two things mean the same exact thing.
Okay.
It is written differently.
Right.
And the third one is using a fraction. This is the same exact thing over and over, just written differently. There we go.
6/9, gotcha. Now, would you do anything with that fraction if you were actually trying to say that we had a certain proportion? Like, you have 6:9, looks wonderful, not much we can do with that, it's gonna stay like that. And then you have 629 in words, that's a wonderful way to write it. What about 6/9? Is there anything you would do that to make it a little more simple, or to make it the same ratio but with different numbers?
Yeah, you could be able to simplify it.
Okay.
So let's think of a number so what is the multiples, which is 3, 6, so we could do this by 2.
You could divide it by 2. Can you divide 9 by 2?
Yes, we can't. So we need to
Let's try a different number than 2. How about that? What other things, what can you divide 6 and 9 by?
So we can divide it by 3.
There you go, let's give that a shot.
Let's just go one number up. And that equals 3, and that equals 2.
Good. So just in your own words here, is 2/3, right? This one you have here, does it mean the same thing as 6/9?
Yes, it does. It's just simplified into a simpler number.
Gotcha. So let's go back up and go from the bottom to the top, go this direction. Can you write this 2/3 in words and then write it with a colon at the top, please?
Yes, we can.
Since they mean the same thing.
These mean the same thing.
Yeah.
So this would be equal 2 to 2. I mean 2 to 3.
2 to 3. There you go. Good.
And then this would be equal to 2 colon 3.
Good job. And not always as obvious at the beginning with a colon or a word, but a little more obvious when you have a fraction there. So I like the way you translated that. Yeah,
Perfectly
good start.
done. So you got your equivalent fractions. That brings me into the next thing. The autumnal equinox
Yes,
is today, the
that's
first
right.
day of autumn, the first day of fall. And a lot of students, I talk to them about the equinox happening today, and then they go, well, what's an equinox and what's the difference between that and a solstice? So an equinox is when you have an equal amount of day and night. Those hours are the same. So that's why it's an equinox. You have one now, the autumnal one, and then one later in the year. A solstice is when you have the longest day or the shortest day based on the amount of hours of sunlight. So that's the difference between an equinox and a solstice. Just remember, equinox equal number of hours, day and night.
Right.
Solstice, longest day or shortest day. But now it is time for today's Math in the News. And there we go once again for our Math in the News. Today we are celebrating 20 years of Do the Math, run by the Kern County Superintendent of Schools office. I have been fortunate enough to be here all 20 years, but I would not have been here if it were not for you. So in studio we have Laurie Maclin. And Laurie, I've got to tell you, when I first saw you this afternoon, and I can tell you right now, and John has been here just as long, you look the same. Does she not? She does. She looks exactly the same as she did 20 years ago. Well, easy there, sister. Hair gone. All right? So hair dye, hair gone. But anyway, Laurie, you were the one that created Do the Math. So explain to us, you know, everybody watching, they've been watching for a long time also, how did this start?
Well, the first instance of the inspiration for Do the Math actually came from my idea that a lot of kids are at home and they don't know how to do their homework, and they get really turned off, especially for math, if they are getting all their homework wrong and getting bad grades. And likelihood that most of the parents don't know how to do the homework either. So, or if they do, are not very good teachers.
Right.
So I just thought that it would be a cool thing if we had a program that would address this and the kids could call in.
And right here, we've got some footage right here of some of the early days.
All right, welcome back. We are doing
Oh, Fran.
and they averaged 180 miles.
How do we find the surface area of objects?
Fran is going to jump into the middle school. And Fran?
What is 15%?
3 players play 4 rounds of a game and
All right, well, there we go.
$60.
A lot of people there bringing back a lot of memories right there. And you remember all those folks?
Yes, I do.
Indeed, I do as well. It was quite the adventure back there. So when you had this idea, obviously you had to present this to the county office.
Well, yes, and that always involves money.
Yeah,
And
right.
so we had about a year to get the money together, and we had to get corporations to help us, and we had to line up the money for the lights in the studio, the sets in the studio. Then I got this inspiration that the school districts would really like this idea, so I went around trying to talk school districts into sponsoring the math tutors. And luckily, the first one I went to was at Greenfield, and she totally bought into it. And then I was able to go to Panama and to Bakersfield City and the high school district and get their support too. And so that really made it a lot easier.
And I can tell you, 20 years later, they're still supporting the program.
Because they know that it's something that's needed. That's why.
Right, they see the value of it.
Yes.
So you present it to the county office and they go, fine, you can do your little thing, get the money for it.
Yes.
So you went to all these places, you got the money for it, and then how did you remember, like, how did we get wrangled into this thing?
Okay, well, what happened is at that time, there were not very many programs like this, and the only one that was worth their salt was down in San Diego.
Right.
So we went down to San Diego and visited the program and basically cherry-picked a few ideas. So then the next thing that had to happen was that the people from the school districts had to come over here, and we went through a stupid interview process that did not work at all.
Okay.
And tried people out for your job.
Right.
And here was Michael sitting over here being a phone tutor, and all the time we had the best host for this show, and we wanted to showcase good math techniques as well as a happy humor laden show that would make people want to do math.
Right. And I think they've got some more footage here to show us right now.
Well, we've
Oh,
got our
great.
first
I didn't
poll
know
of
it
the
was this
hour.
Oh, look at that hair.
It's got to do with money. It seems as though Unita, and I need it too, but Unita needs some extra money. She babysits currently, and she's getting $3 an hour to babysit. However, she just got offered another job. So she's got 2 jobs and the kid's still in school. She can get $6 an hour.
Now, this is the same problem James auditioned
other
with
kids.
when we saw his audition yesterday as
Problem
well.
is, Unita needs to make $65 a week.
I don't know where that guy went. Handsome-looking devil, though, eh?
Yes.
And she has to get that $65 a week, working only 15 hours.
I thought once they had that, they burned that thing once it was
No,
all done.
they
They're like, oh, yeah, thanks
save
for the
all of this
audition.
stuff.
Kid, get out of here
It
now.
all goes in the archive.
The crazy thing about having somebody audition is that sometimes they can do great on the audition, but they're just a total flop on the show and can't handle things on the spur of the moment. Now, Michael, he can handle anything on the spur of the moment, even really bizarre things.
We've had many bizarre things happen over the years. I remember one time you had your hands up in the air like, what did you just say? And I remember that. I was like, I didn't think I said anything wrong. I don't remember, And it was something very innocent. But I think the way it came out
It got a little twisted.
seemed a little like, it could have been taken that way. But it was all in
Yeah.
the play of math.
Right.
And everything was good. Everybody was fine with it. And it just kind of sounded a little. There's the staff from the first year.
Right.
There we are. Boy, that's a long time ago. There's Mr. Lenko. He's been here the entire 20 years as well. Mary. There's Laurie. Out there making those kids work. Manya's coming back also.
Oh, good.
Good.
She's in the Bay Area?
Yeah, she is up in San Francisco, up in the Bay Area. She's coming back. And Hilda is now working again.
Oh, good.
And
Karen's coming?
Karen's coming in. Chuck's going to Skype us. He's up in Seattle now. And, well, I saw Big Mac in there. I mean, we might be able to wrangle her back on there somehow. But anyway, because of you, the show has been a success.
No,
I cannot
because
tell
of
you,
everybody.
going out in the community, how many people remember Do the Math. I was actually at a park last night, and there was a gentleman, we were playing pickleball, and he goes, you're the Do the Math, right? And I go, yeah, why do you say that? And he goes, I used to watch it when I was younger. I still watch it, even though he's an adult. There are as many adults that view the program as there are students, simply because it is informative, creative, some of the things we're doing, humorous, lighthearted, things like that. And it's all, we got started because of you.
Well, thank you. But it's a group effort, believe me.
It is, and there's a lot of people behind the scenes that people never see, and they will during the year. Trust me, everybody's going to be shown this year during the 20 years, whether they expect it or not right now.
Okay.
The things are going to be happening at different points of the season. But I don't want to get too much away because they can hear me and see me right now. So
Alrighty.
those people behind the scenes.
Okay.
But anyway, Laurie, once again, thank you for coming in,
Well,
taking a
thank
little
you,
time.
kiddo.
And all is going well in retirement?
Yes. Yeah.
Hey, you know what? I can't wait to say it myself. Yeah, all is going well in retirement.
When is that?
All
Long
right.
time.
636-4357 is the phone number. That is today's Math in the News. All right, we are celebrating 20 years this year, and as part of that celebration, as we do every year, students that phone in this week, if we do one of your math problems on air, you will receive a ticket to the Kern County Fair, and that is started today. So right now, I believe we're going to go to the phones, and Naomi, how are you this afternoon? Are you there, Naomi?
Yes, we are.
All right, and you're at Stockdale Christian, correct?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on. So you can go ahead and read it.
Okay. So I have to write the percent as a decimal, and it's just 2%.
So we want to write 2% as a decimal?
Yes.
Gotcha. Okay, Naomi, what do you know about this kind of problem? 2%. I've written it on the board here, and we just have the number 2 and then the percentage sign. Let's do a different example. What if you have like 53%? How would you rate that as a decimal?
0.53.
Okay, and how'd you know that? 0.53. What is the way in your mind that you can keep that straight? What is the way that you can think to yourself, oh, if it's 53%, it's 0.53? What goes through your head when you do a problem like that?
Because 100% would be the full 1 in a decimal.
Okay, gotcha. So if you had 100%,
That would be
1.00. Gotcha. Is there anything specific, any tricks that you use here? So for instance, if you look at the number 53%, right, where is the decimal on the 53?
Repeat that question again.
If you looked at the number 53%, right, this little example that we have here, if you think about 53%, every number in the world has a decimal, right? So where is the decimal on the number 53?
Then it would be,
If you don't see it, it's at the end, right?
yeah,
So 53 point, right? 53.0, whatever else it is. And you changed that to 0.53. So which way did you move the decimal?
I moved it to the right, but it's supposed to be on the left.
Yeah, we're going to move it to the left twice to make it into a decimal, right? So that's
Yes.
maybe one of the strategies you can use with this 2%. Now, this is a very often missed kind of problem, this 2% problem, because some students forget to move it 2 times. But we know it has to go to the left, okay? So
Yeah.
where's the decimal on the 2 in 2%?
After the 2.
That's right there at the end, after the 2. So how many times are we going to move this to the left?
For the 2, just once, but for any other number, it would be 12.
Well, every number, not just the 2, right? And not just every other number, but the 2 as well. We want to move this one to the left 2 times. Now, here's the problem with that. That's kind of a strange deal. We move it once past the 2, and then all of a sudden there's nothing there. So what do you put there in front of the 2?
A 0.
That's it. You got it. So we have a 0 and a 2, and the decimal goes right before there. And the key is here, sometimes students will look at 2% and think automatically 20%, right? And they'll go 0.2, or they'll only move it one time, kind of like you were saying, but we want to make sure you move it twice. So go 2 places to the left, and you can move that. Do you have another one that you want to work on real quick?
Yes.
Okay.
So this one is the same thing. It's write the percentage as a decimal, and it's 3.5.
I was really hoping you'd have a decimal
I was
in
going
the
to say,
percent.
if you didn't have one, we'd come up with
That's
one.
right. We were thinking along the same lines.
Oh, it's gonna be
Me and
good.
Mr. Crushine were thinking that, yeah, we need to have a decimal in the percent. So when you have a decimal in the percent, this really throws students off a lot. They look at that and go, oh, now we got percents and decimals. I'm supposed to change it to a decimal, but it already has one. Don't let it throw you off. It's the same exact process. Tell me what to do, Naomi. Where are we going to move this decimal?
To the left.
Let's move it to the left. How many times?
Twice.
That's it. 1, 2. Tell me what the final answer is, please.
35.
There is a 35 in there, no doubt about that. The numbers do not change. I completely agree with you.
Wait, so 3.5.
That's what it was at first. You're right. It was 3.5%, but we've moved it 2 times to the left. So now, how would you say this number? What goes in front of the 3? Go ahead.
Would it be 0, 30, 0, and then 35
That's it. You got it. And where's the decimal?
after the 35?
Not after. Before, in the very beginning. Because remember, we're moving to the left, okay?
Oh,
So we're moving
okay.
2 places to the left. And so when you move the decimal on the 2, it went 2 places to the left. We had to add a 0. When you move the decimal on the 3.5, same thing. 2 places to the left. has a 0 in front of there. Don't worry about the fact that it had a decimal at the beginning. It's still going to have a decimal at the end, and we still do the same exact process. I like that you asked that question. Good job.
Nicely done, Naomi. Thank you very much for phoning in today. Don't forget, we do have phone calls available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We are celebrating 20 years of Do the Math. Thanks again to Laurie for coming in, the creator of the program, Do the Math. In studio, we have Kadyn, a 6th grade student from Williams Elementary. Head on over to the board, young man. You earlier were talking about ratios and different ways to represent them. So I've got your homework paper here. And how about you select a number between 1 and 10, and we'll do that problem.
Okay, let's pick my lucky number 7.
Lucky number 7. Before we start, why is 7 lucky for you?
Because it's my dad's lucky number.
There you go. And I'm going to tell you why 7 is everybody's lucky number. Because if you roll dice, if you take a pair of dice and you roll them, the most frequented outcome is a 7. There are more possibilities of getting a 7 than any other number, which is why a lot of people think 7 is their lucky number, if that's what they're talking about.
It's mathematically based. We love those answers.
Yep. Let's move on. Here we go. How many meters per second faster is 30 meters per second? Okay, so we've got 30 meters per second, then 100 kilometers per hour.
Whoa.
Okay.
You picked a nice one.
Oh, great.
All right. Express your answer as a decimal to the nearest tenth.
Okay.
So I'll read it again. How many meters per second faster is 30 meters per second than 100 kilometers per hour? So you're going to need to change some units. And so, Kadyn, you've got Scott right there to help you out. How do you think you want to start?
He's thinking. All right, so you can go ahead and grab your red pen there. And we're going to definitely have to change this ratio, right? This is 1
To 1
hour, right? 100 kilometers in 1 hour.
Okay.
What do you want to do to that, and where is your goal? What's your goal? Where do you want to change that to?
I obviously want to change the 100 into a lower number.
Well, don't worry about the number so much, but tell me what your goal is as far as units. What is the question asking you?
Oh, the unit is to be able to make this question equivalent to this.
We want to have the same units. Would you agree?
Yes.
Gotcha. So our goal here for this one right here, right, way over here somewhere, is we want to change this to meters, and we want to change the bottom to seconds, right?
Yeah.
That's the goal. Okay. How do you change one? You want to deal with the 100 first, or you want to deal with the 1 hour? It's up to you.
I think I would want to deal with 1 hour first.
Okay. So how are we going to change 1 hour? What would you like to change it to?
We could change it into minutes, which is 60 minutes.
Gotcha. So one of the ways we can do that is, would you agree that if you multiplied this ratio times 1, it wouldn't change? Would you agree with that?
Yes, I would.
Right, so nothing would change at all, right? We're just going to make this 1 look very specific. You told me there's 60 minutes in 1 hour, right? So if we have 1 hour here over 60 minutes, 1 hour divided by 60 minutes, these are the same thing, which is just 1, right? So we're really just multiplying times 1, but now we've changed our units from hours to minutes. Are you done yet? What do you need?
We need seconds.
Aha, so what do you want to do next?
So we need to, okay, I see. So every minute is 1 second. So
Can you write that down?
So 60 minutes times 60 seconds.
Aha, gotcha. So what we've done here is, if we're writing this in mathematical terms, right, we've already crossed off your hours, right? Those cancel out. We want to cross off the minutes. So what you said here was 1 minute is 60 seconds, right?
Yes.
And now we've crossed off the minutes too. So now we've changed our hours to seconds. Whew, we've done that so far.
Okay.
So far the math problem is, tell me what we're going to do here. What would be the math problem? We're not done with the problem, but what would be the math problem? 100 divided by?
Divided by 60 minutes.
Divided by?
60 seconds.
Gotcha. So it's going to be a pretty small number. However, we're not quite done because we haven't changed kilometers to meters. So what are you going to do with that one?
Okay, so we're always going to divide it by something.
Yeah,
That
that's right.
question is what something.
And the kilometer is going to be on the bottom because we want it to be able to divide out, right? We want it to be able to cross off. We're going to cross off these kilometers with these kilometers. If you have 1 kilometer, can you change that to meters?
Let's think. I don't think so.
Well, how many meters are in a kilometer? Do you know that answer? Because they have the same root word in there, right? You have a meter, and then you have a kilometer. You know what that word, that prefix kilo means?
I learned it in 5th grade, but I can't remember at the moment.
And if you're in most other countries in the world, you learn it too, because they all use that metric system, huh?
Yeah.
Now, what is the metric system based on?
The metric system is based on
How many fingers you got?
5. Oh, it's
No.
it's kind of
2
based.
hands.
10.
10, right. Metric system based on 10. It
10.
totally makes sense. The rest of the world uses this wonderful system that is based on 10, and if you ever forget, you can look at how many fingers you have. So, do you think there are 10 meters in a kilometer? A kilometer is kind of like a mile, okay? That's our equivalent to a mile.
Okay.
And a meter is kind of like a yard.
Okay.
Think there's 10 meters or 10 yards in a mile?
10 yards in a mile.
No, not quite, huh?
No,
That's not
no.
good. Do you think there's 100 yards in a mile? Not enough, huh?
No.
So what do you think that word kilo means? It's not 10, it's not 100. What's the next version or the next increment of 10? 10, 100, and then what else?
10, 100, 1.
Go higher. 1 would be going down, you're exactly right. So we have 1, 10, 100, and what's 1 more 0?
1,000.
1,000, that's it.
There we go.
So there are 1,000 meters in a kilometer.
Okay.
And now what we have is we've canceled all of our units. So tell me what's going to happen now. We would do 100 times.
We're going to times it by 10 to be able to get that extra 0.
No, look at the numbers we've written here, okay?
Wait.
Slow down. 100 times what?
Oh, 100 times 1,000.
And then we would divide by,
We divide by
right here.
60 minutes.
And then divide by?
60 seconds.
Gotcha. So we have one big, huge math problem here, right? And what we
Yes.
love when we have a huge math problem here, okay, we can cross off a bunch of zeros, we can do a bunch of numbers, but we also like calculators.
Yeah.
Calculators work out pretty well.
Yeah, they do.
So we would have to do 100 times 1,000 divided by 60 divided by 60.
Now remember, you've got 30 meters per second we started with.
Right.
Okay.
Gotcha. So we're going to do that ratio once we change this one, right? We're going
Okay.
to do some changing once we've done that. So do we have a calculator that's done this for us? We can do this. We can say, hey, that 0 cancels with this 0, and this 0 cancels with this 0, and this is just a 1. So now our final problem that we need to do here is 1,000 divided by 6 times 6. What is 6 times 6?
6 times 6 is 36.
Gotcha. So this problem now is 1,000 divided by 36. You want to see if you can work that out on a calculator? Oh, we have a helper. Heck,
Here we go,
Yay.
27.7,
Okay, so
which will round to 27.8.
27.8 meters per second, okay? So this number here, right, at the very beginning, really equals 27.8 meters per second, and we started with 30 meters per second. Can we have that problem one more time? What is the final question?
So how many meters per second faster is
Gotcha.
30 meters per second than 100 kilometers per hour?
Okay, so let's make sure that the question makes sense.
Okay.
Do you agree that 30 meters per second is faster than 27.8 meters per second?
Yes.
Yes, so we know that the question makes sense. The question is, how much faster? And what would you do with this now?
So now I would take 30 and then I would subtract 27.8.
I like it. Right over here, I want you to do that problem. And since you're doing it in red, we can see exactly what you're doing.
Yep.
I like the way you think.
Thank you very much, sir. 0.8.
And what are you doing again? You're subtracting?
So, oh,
That's all right. Just
That's
give you a little
fine.
more room.
okay.
Where's the decimal on the 30?
The 30 is going to be right in between them.
No, not quite.
Wait.
On the 30, just like we were talking about with our caller today, every number in the world is a decimal, and if you don't see it, it goes to the end, right? There
There we
you go. Gotcha. So we want to go over here and see if you can erase. There we go. That one. Now, when you're subtracting decimals, is there something specific you need to do?
Subtracting decimals. You need to make sure that they're both in the same place.
That's right. So maybe you should rewrite this problem a little bit to make sure that those decimals are lined up. Can you rewrite the problem right underneath, please?
Okay. So we have this,
Yeah.
and then 27.
No, line up those decimals. Don't line up the numbers, line up the decimals. Okay?
Dec-
Can you draw your 27.8 again? There you go.
Okay.
Yeah, we got to line up those decimals. That's the most important part.
Yeah.
With multiplication, no big deal, but with subtraction, you got to line them up. 27.
Point.
Good for you. That's the problem we want to do. Okay, draw a line, draw a minus sign. And what's the number that's going to go after the 30 so that we have a digit there? See right where my little pencil is?
Yes.
What's going to go there?
There's gonna go a
If you don't see a number, what goes there?
0.
That's it. Can you put a 0 there? Okay, do some subtraction. See what you got.
Okay, let's see. So this is gonna be canceled out because you can't minus 0 from 8.
Okay.
This is gonna be canceled out too because it needs to borrow. So
Okay.
this is gonna be canceled out into 2.
Okay.
Then this is gonna make it into a 10, but then this one still needs 1, so it's gonna be turned into 9.
All right.
And then this one is finally gonna be a 10.
So you're doing some serious borrowing there, huh?
Thank you. So then 10 minus 8 is 2 points because we need to bring our decimal down. Then 9 subtracted by 7 is 2.
Gotcha.
And then 2 minus 2 is very easy. It's 0.
Gotcha. So you have 2.2, and what are the units we're talking about here again?
Meters.
Meters per
Seconds.
second. And the final answer to the question is it's 2.2 meters per second faster than the other rate that we converted, right?
There you go.
I like
Great
the work you've
problem
done there.
right there, Kadyn.
Thank you.
Nicely done for some great work right there. You've got yourself a meal courtesy of our friends at Chick-fil-A. Hey, there you go. I raised both fists on that. Yeah, Chick-fil-A, baby. There you go. All right, everybody loves Chick-fil-A. Hey, we've got phone tutors available until 5:30 this afternoon, and we'll be back with more right after this.
This week, Lab TV travels to NAVC Carter Rock in Bethesda, Maryland, to meet an engineer who creates some really hot materials called ceramics.
All of you know about household ceramics, the things you see in your house. Your house might have bricks on it, you have dinner plates, you have coffee mugs, there might be tile on the wall or on the floor, and everybody has in their house this huge piece of ceramic, and that's the toilet. It's the biggest piece of ceramic that anybody has in their house.
Ceramics are also used in places where you might not see them. They're called technical ceramics.
Technical ceramics are used to make capacitors. It's in almost every electrical device that you have. They're used to make fiber optic cables which transmit light. Maybe the most famous example of a technical ceramic is the space shuttle tiles which coat the entire bottom surface of the space shuttle. Those ceramics are there to protect the shuttle when it's coming back into the atmosphere from burning up.
Ceramics are strong, hard, and durable. They have very special properties that give them lots of advantages over some other materials.
A ceramic is usually a very high melting material. It has high hardness and it has a lot of brittleness, but it is made from a metal combined with another element. And the other element is usually oxygen, carbon, nitrogen, or boron.
Probably the best thing about ceramics is their high melting temperature. That lets engineers use them in places where even metals would melt.
The kind of materials we work with would have melting temperatures from about 1700 degrees C up to about 3000 degrees C. So your oven at home could probably get to 250 degrees C. When you stand by a campfire and see those glowing embers on the bottom, that temperature is about 1200 degrees C. And the highest temperature that you would see at home is that filament in that light bulb is way above 2000 degrees C.
Another great property of ceramics is their hardness.
Ceramics are very hard, and based on Mohs scale of hardness, the softest material is talc, the hardest material is diamond. The materials that we work with are very close in hardness to diamond. If you need to cut something, you put ceramics on it and it can grind and cut almost anything.
Ceramics can also withstand chemicals and erosion, but they're not perfect materials. Unfortunately, they can be brittle and they can break.
We try to make ceramics that try to get rid of the brittleness. That's the biggest drawback of ceramics. So we don't want to take something that we make, drop it on the floor and have it break.
Dr. Zakowski and his research team use a process called sintering to create their ceramics.
At our laboratory, we use primarily dry powders. We mix 2 or more different chemicals, then we put it into a mold, and press it into a shape. It's usually in the shape of a disc, a thin disc. Then we take this disc and put it into a furnace. That's the most important part of making a ceramic, is to put the material into a furnace and put tremendous heat on it. You have to heat it between 1700 to 2200 C.
They heat the disc to just below its melting point. That causes the powders to stick together and form a strong crystal structure. Now it's a ceramic.
Ceramics are going to be with us forever, and they're going to be used in many, many applications. We are particularly looking at ceramics for Navy applications in engines. We want to put ceramic materials in there that allows the engine to operate at higher temperatures and derive greater efficiency from the fuel.
Dr. Zakowski and his team have received 20 patents for their work, and they're still trying to create new and better ceramics.
That's exactly right, and that's part of our job. And everything that we make here is very new. It's never been done before, and that's the exciting part of what we do.
To find out more about ceramics and their amazing properties, check out labtvonline.org.
All right, we always anticipate these guests, but they're back once again, our friends from Science for Kern. All right, I know Michelle's always got some great activities. Michelle, quickly, just a little bit about Science for Kern for first-time viewers.
Hey, thanks for having me again, Mike. Science for Kern is a mobile lending library that's fully funded by Chevron, so there's no cost to our Kern County educators. The units focus on grades 3 through 5 and our next generation science standards aligned. If any of our 3rd through 5th grade teachers in the county are interested in reserving one of those, we currently have 10 units to choose from. Those can be found on the scienceforkern.org website. And I'd like to mention that we're getting ready to launch a new unit called Intro to Engineering. It's going to be super cool.
All right, well, I know you've got Kadyn over there. He's a 6th grade student, and he sees kind of what you're going to be working on today. And I think since class was virtual all last year, he wasn't able to do it. So big day for Kadyn. Why don't you guys take it away?
Oh, it's always great when you can do science with an eager young scientist. So Kadyn, we're going to be investigating floating and sinking. And so I brought with me today a couple of books that you might be interested in checking out later. There's one called Toy Boat, and another one that's nonfiction all about floating and sinking. And maybe some of our guests out there in TV land might be interested in checking those out too if they want to know more about what we're doing today.
Okay.
So, as I mentioned, we're going to be investigating floating and sinking. So let's start with a couple of just regular items. This is a fancy painted rock. I'm going to let you hold that one. Okay. And a really cute soccer ball rubber ducky. Yeah. I'll let you hold that one too. And make a prediction as to which item, the rubber duck or the rock, which do you think will float?
I think definitely the rubber ducky.
Okay, and how come you think the rubber ducky will float?
I think because the rock in my hand just feels a little bit more heavier than the rubber ducky. The rubber ducky feels like way lighter, almost as light as a feather.
Okay, so it sounds like you're thinking that maybe weight or mass might have something to do with it?
Yes.
How about which one should we test first?
Let's test out the rubber ducky.
All right. Let's try it.
3.
All right, so what do we see happening in the water?
He is floating.
Yeah, we've got a floater there. So let's right the rubber ducky there.
There we go.
There we go. And let's test our rock. Let's see what happens there. Yeah, exactly as predicted, right?
Yep.
We've got a sinker and a floater. So let's get those out of our water there. Put those here to dry. Now, we've got some household aluminum foil, just like you'd find in your kitchen. I just cut it into some squares for the next part of our investigation today.
Okay.
And then I do have a container over here for later of 50 pennies. Now, take my piece of foil and just crumple that up into a ball.
There we go.
All right. So if we were to place the ball of foil into the tub of water, what do you think would happen?
From its weight and mass, I think it would be able to float.
You think the foil will float, and its weight and mass based on, are you comparing that to anything that you already know?
Yes, I'm kind of comparing it to the rock, as I felt earlier.
So what you're saying is that maybe the foil feels about the same mass as the rock? Okay, well, let's see what happens.
Me?
All right, it floated too. Now, let's put that over here too to dry.
Okay.
So we take another piece of foil. Do you think that you can wad that foil up in such a way that you could get it to sink?
Okay. Let me think. So, okay. I'm gonna let it have a lot of inside pieces to where it could just sink and the water will just take it in.
Okay. All right, well, let's try it.
So.
All right, so,
Wait.
and we got another, no.
There we go.
So, explain, what happened there?
So what happened is that I crumbled up the foil, not intensely into a ball, but I crumbled it up just enough to where there was open pieces to where the water could just flow right into the paper and make it sink down.
All right, so all right. Interesting findings there.
Thank you.
So let's take another piece of foil, and I'm gonna slide my water over just a bit so that you can use this table surface if you need it. And you can go ahead and quickly fold that into, so can you name some other things that float before we get into this next part?
Well, kind of ironically, a boat, since that rhymes with float.
Very nice. That's awesome. I love that. So boats float. And so think about all the different, I'm thinking about like small rowboats. Can you name other kinds of boats?
I can name a bunch of them. I could name a cruise boat, a fishing boat, a lifeboat. What other ones? Kind of like a cargo boat to where it like delivers cargo.
Okay, so let's go ahead and fold this while we go ahead and talk some more. You can go ahead and start folding that up into a boat for me.
Okay.
So, you mentioned a cruise ship, and the first boat that came to my mind was a small boat. I find it really interesting that giant cruise ship is able to float the same as a rowboat. Do you have any ideas around how something so enormous as a cruise ship could float?
Because
shall we put this in the, keep talking.
Okay.
Are you happy?
I'm happy with it. I'm happy with it. I kind of crumbled it around. Oh, there we go.
So tell me about a cruise ship, real quick, before we test our pennies.
A cruise ship. So I think what happens is that it's able to float because it has, like, when the people built it, they made sure that it could actually float. So they tested it out, just like we're gonna do today with the pennies and everything.
So go ahead. We're gonna start loading pennies, then we're gonna talk about cruise ships some more.
Okay.
So go ahead and start putting the pennies on there one at a time, and then keep talking about cruise ships.
Okay.
All right.
First one. Okay, so a cruise ship can float because even though it has a massive kind of like weight on it with people and then whatever else is on there that we don't even know about, I think it floats because what happens is that if it were to sink, I'm pretty sure that would never happen, and they've assured us to this. And I think it's kind of like how I'm doing right now. I'm setting pennies not just like right in the middle so it could drop. I'm putting them equally, so an equally amount of pennies. So
equally distributing the weight around the frame of the boat?
So it could still float. So as if this stack were on this stack, and then I'm pretty sure that with like about 5 more pennies, it would drop this whole side of the boat right here.
Okay, you think so?
Yes.
All right, so let's keep loading with pennies and see. Oh, look at that. We're still continuing to float. Looks like we've got 4.
Now I think just for good measures, let's do this.
Well, we started with 50 pennies in our container. Let's keep going and see if we can load all 50 of those pennies on there.
Let's see.
Before we sink our boat.
Let's see.
Well, we're having some incredible success there. All right, and your strategy of displacing the weight around the boat definitely seems to be working. All right, look at that. Oh, we just have a few more pennies in our container.
There's a few more. Come on, boat. You can do it.
Come on, almost.
You can do it.
Almost.
Oh, just about like 5 more.
All
5
right.
more.
You've got this. Almost. I'm starting to see that potentially we can have
Ooh,
a sinker
okay.
going on this end.
So I think I'll try to put a little bit of weight around here, around the middle, so that way it can.
Super strategic in where you put those pennies. All right, fist pump on that one. That was well done, Kadyn. So if, let's say, as we wrap up our activity this afternoon, let's say that we wanted to put 100 pennies on our foil boat. How might you modify your design?
Okay. So I'm not gonna do anything except for try to fold these up a little bit, because as you can see, as I'm modifying it, the water is starting to go down. So I'm gonna try to put the edges up a little bit more.
Okay.
Uh-oh.
That's all right. And all right. Yeah, so then your idea would be
so
to
now it's sink.
Yes. But I would imagine it would be really interesting to test later with getting all those edges up a little higher potentially, and maybe we would be have success with 100 pennies on a foil boat. Well, super well done, Kadyn.
Thank you.
It was great working with you.
It was great working with you too.
All right, thank you for that, Michelle, again. And once again, Michelle, can you give us the website in case somebody wants to contact Science for Kern?
Yes, that's scienceforkern.org.
All right, thank you very much. And speaking about students doing a lot of different projects, right now we're going to learn a little bit more about law enforcement with our friends at CTEC.
The best part of my job here at CTEC is actually being able to share my experience and knowledge and training that I have with my students. I feel that it's important for students, especially if they're interested in the law enforcement career, to get a firm foundation of what it is that the job truly entails. A lot of times people watch the news, they watch YouTube, social media, and they get a perception of law enforcement which isn't correct. My philosophy of teaching and learning is that I believe that, again, being able to share my experience, my training, and all the education that I have in this field and being able to impart that with my students. I believe that that's a firm philosophy, especially here at the Career Technical Education Center and the ROC as well. And that's why our educators here are so great, because we are able to impart that knowledge and training and experience onto our students. I believe that if you're interested or have maybe some type of small inclination that you might be interested in this career, definitely give it an opportunity. Sign up. You will get a lot of hands-on experience. The school recently bought me a training simulator, which we haven't implemented yet this semester, but we will by next semester. There's physical training involved every day. We learn the fundamentals of the criminal justice system. We do many things that you would normally get in an academy setting. Physical training is done every day. Every day we are doing physical training. That includes cardio, weightlifting, and whatever else I plan to implement on that day. But every day we are doing some type of physical training. After that, we are in the classroom focusing on, we have a book, a criminal justice book, we're reading, analyzing theories and themes, also getting into some body cam video, analyzing those, having group discussions in the class about it. I mean, there's a variety of different things. We'll get into gun belts pretty soon and setting those up for the students, practicing defensive tactics. We'll incorporate defensive tactics at some point. So there's a variety of different things that we implement during the class. So day to day, it could change from day to day, of course, but that's typically our schedule for the day.
Hello, I'm Clay Castillo-Baez. I'm in the law enforcement class. I chose this class because I really wanted to get involved with the police academy and everything that has to do with law enforcement.
My name is Judith and I'm in the class of law enforcement. I've always been interested in the category of law enforcement and criminal justice, so I just kind of looked more into it.
My name is Jeremiah Zaragoza. I am in law enforcement. I'm most excited to get the experience of learning how to do police tactics and police training. I had high expectations and they still are high till this moment because I know this is the dream I want to pursue. Well, I am getting training at an early age. That is something I can't say. We are getting handcuff training, police tactic training, and just all that other stuff. We're learning how to talk to people if we're ever put into this, like a certain scenario. So that's really helpful.
My name is Estrella Leon and I'm in law enforcement. I'm excited to learn more about law enforcement and what they do and about the criminal justice system. I think there's a lot of opportunities that you're going to get at CTEC, especially in law enforcement and a lot of the other classes, because you get to gain a lot of experience and decide if this is really a path that you want to take.
We also, I incorporate a daily language review because this class, if you do take this class and you successfully complete the class, you will also are eligible to receive 5 English credits because this class involves a lot of report writing, right? Because in law enforcement, we do write a lot of reports. We document a lot of incidents that happen out in the field, and so English is crucial.
I do recommend this class just because, I mean, if you're really interested in law enforcement, but if you're just here to get out of the high school or whatever, I don't think so, just because you won't take this class serious, and I mean, it won't benefit you in the future if you're not looking into being in the law enforcement and criminal justice. Personally, I don't think it's hard yet, but I feel like it'll be a little bit harder in the future whenever we get more into the semester, but as of right now, I'm enjoying it and it's not that hard. I'm really enjoying this class because, how I said, I'm really into the criminal justice, and I like physical training and being around people that are actually enjoy doing exercises and stuff, so I guess it just suits me.
All right, some great programs over at the ROC and CTEC. Thank you once again to all of those students. Those are completely produced by those students at CTEC, and we want to thank them once again. Another great segment, that one about law enforcement. We're celebrating 20 years here on Do the Math, and we do have phone tutors available most Tuesdays and Wednesdays between 3:30 and 5:30. Kadyn is a 6th grade student from Bill L. Williams Elementary School. Been there since kindergarten. And did you like the activity with Science for Kern?
Yes, I absolutely did, because I was very excited I gained 50 pennies on
Hey, there
my
you go.
boat.
So you did pretty well with that. I know that your design about not crumpling it up a lot and seeing if it could sink, and that worked. That was a pretty ingenious way you did that.
Thank you.
And then a lot of students make a smaller boat, you know, and they can't get as many into it. But the way you came up, I like the little cruise ship thing in there, and you spaced it out nicely. I mean, because if you put them all at one end,
then
it would have gone down,
soon it's
right?
going to go down all the way.
You didn't want that. So anyway, I know that you've been working on proportions and ratios.
Yes.
We did one of your math homework problems, and we've got another one for you right now. So I'll read the problem. A dozen cookies cost $3.99. Now, do you have a favorite cookie?
Chocolate chip.
Those are always good. Nice standby right there. At the same cost per cookie, how many dollars should 8 cookies cost? Express your answer to the nearest hundredth. All right, so Scott's got some basic information up there. You guys, go ahead.
Okay.
All right, Kadyn, where do you want to go with this one? I've written the information up down on the board there. $3.99 a dozen, right?
Yes.
And we want to know, the question is how much for 8? And there's quite a few ways to solve this. So I'm going to see the way that you are thinking about it. Go ahead and think and talk out loud so we can kind of get your idea about what's going on there.
Okay, the first thing I want to do is get rid of this and make it a 12, because 12 is a dozen.
Okay, good start.
So then the next thing I want to do is, since it says for 8, I want to see what just one donut cost, and times that cost by 8.
That's a great way to do it. I like the thinking there.
Thank
so
you.
how are you going to figure out how much for one cookie?
Let's see. So I think I would divide the first number, which is $3.99, by 12.
Okay, good idea.
Thank you.
And how'd you know dividing?
Because you have to get to a smaller number to be able to get to the bigger answer.
Okay, let's see what you can do here.
Okay, let's see.
$3.99 divided by 12. Now you have a decimal in the $3.99, right? Where does the decimal go in the answer?
So the decimal goes straight up.
Good for you. Put that there. All right, does 12 go into 3?
No, it doesn't.
All right, what are you going to put there then?
So we have to do nothing, and we have to go on to 39.
Gotcha.
So now 39, let's think, well, 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. That's the closest we can get. So we have to do 3.
Gotcha. And this is exactly why I was asking you, does 12 go into 3? Hold on just a second. Does 12 go into 3?
No, it doesn't.
No, it doesn't. So right above the 3, then, you need to actually put a 0 here so you can take up that space. And I talk to my students about that a lot because we don't want to lose that space there, okay?
Okay.
Because you told me the answer, which was 0, but where does that 3 go now? Because you said 12 goes into 39, right? So it should go above the 9 there.
Right
there you go. Super important where you put that number.
Okay.
Proceed. You're doing great.
Okay, so now we go 36. So now we're going to do this and then that.
Good job.
We don't really need to put that 0 there, but I just like to do that for good measure.
I don't blame you.
Thank
Okay,
you.
now we're going to bring the 9 down, right?
So now we have to bring the 9 down
Gotcha.
to make it 39 again.
Hey, we already know the answer to that one. That's good.
Yep. So we have to do it by 3 again.
Okay.
So this is 36. So then it's going to be like this. And so from what I know,
Let me give you a little bit more room. Are you ready?
okay, yeah. And let's just erase that because that's a little surprise.
You're going to bring a 0 down. That's all right. No problem there.
Yeah, from
Okay.
what I know, we can bring a 0 down.
Good. Now,
So-
just real quick, how many times does 12 go into 30? We don't need to actually write it down, but I want to see if this 33 is going to be rounded some other way, other direction.
Let's see.
12 goes into 30 how many times?
The closest we can get is 24. So
Yep.
that's 2.
So that's 2. So
Now,
if
I
it's-
suggest you guys do your multiplication with 0.332.
Yeah. Okay, that sounds
Don't
good.
leave it at 33.
Okay, that's fair. So you
Okay.
said 2 is going to be there because we need to round to the nearest hundredth, which means to the nearest cent. So let's go back up here and see what you got, right?
Yeah,
You said
okay.
it's going to be 0.332, which is kind of a weird number, but that just means 33 cents with a little bit extra.
Okay.
Now, that's how much it is for one cookie, right?
Yes.
So what's the next step?
So now the next step is to be able to multiply. So this is
Multiply times?
This is for one cookie. So I'm
It
going to
is?
time it by 8 now.
Gotcha. Okay, let's see what you can
And
do.
you guys have about a minute, and what I'm going to do is I'm going to help you out here.
Perfect.
Let's go 0.332
Hooray for
times
calculators.
8.
Okay.
And you get 2.656.
6, 5, 6.
I like it.
Ooh.
The rest is up to you.
So
Okay.
that's how much it's going to cost. But if you try to reach in your pocket and get $2.656, that's a weird number. What do you want to do with this? Let's make it a little more simple.
So what should we do with this?
Now remember, they said round it to the nearest hundredth.
Which number's in the hundredths place?
Okay, 6.
Nope, not quite.
Wait.
This first one's the
the
10th, and then which one's the hundredth?
6.
Nope,
Wait.
that's the 10th. That's the 10th place.
The
Underline the 5 because the 5's in the hundredths place, right?
we go, yeah.
Which number helps you round the 5?
Round the 5. This one. This
That's
number.
right. So the 6 is going to help you round the 5, right? Does
So-
the 6 round the 5 up or to the same?
Up
Good job. Up to what?
to 60.
Gotcha. So 2.6, and this number is going to become a 6. Can you put the dollar sign in there?
Okay.
Where's the dollar sign go?
Right.
There you go.
That's it.
Nicely
266 for 8 cookies.
Not a bad deal.
That's a pretty good deal.
That's
I'd
a
take
pretty
that.
good deal. That's a pretty good deal.
So, Kadyn, did you have fun today?
Yes, I did.
Did you learn a little something?
Yes, I did.
That's what we want to hear right there. Hey, phone tutors available until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.